Hello learners, welcome to this course on embedded system design using PIC16F877 microcontroller. In this tutorial, I will be discussing about on how to calculate the object distance or proximity sensing using ultrasonic sensor. So first let us discuss about the fundamentals of an ultrasonic sensor. So an ultrasonic sensor is a non-contact proximity sensor. It's a non-contact, which means from a distance we can able to identify the object. How long is the object? So in that sense, the measurable distance ranges from 2 cm to 400 cm. And the ranging accuracy is of about 3 mm, and the measuring angle, so it can identify the object within 15 degree of its viewpoint. It requires a supply of 5 volt and a working current of 15 milliampere. Let us see how it is made. The ultrasonic sensor has a transmitter and also a receiver. So there is a transmitter and a receiver. So the transmitter will generate the pulses of certain frequency. Then this pulses, as it propagates, when it encounters with an object, it gets reflected back. Then the written signal will be received by the receiver, and based upon the time of flight of the pulse from transmission to the reception, we can calculate the distance of an object from the module. So in order to do this, the ultrasonic module has 4 pins, a VCC, ground, which is a power supply lines, and it has 2 control lines like trigger as well as echo. So the trigger signal should be of 10 microsecond TTL voltage levels. So this signal will be generated by your microcontroller. When I interface this ultrasonic module with the microcontroller, this 10 microsecond pulse will be generated by the microcontroller. So upon receiving this 10 microsecond pulse, the module will generate pulses which it will transmit in the free space. On getting the reflected signal, the echo signal will go to high. So the echo pin will go to high for a time equivalent to that of the object distance. So the echo signal will be high, and that how long it will be high, that will be proportional to the distance range. As I said, the module, it consists of an ultrasonic transmitter, receiver and a control circuit. Now let us see the basic working principle of the sensor. So from a microcontroller, using GPIO pins, we send the trigger signal, and this trigger signal should be for at least a duration of 10 microseconds. Once this is done, the module, what it does, it automatically sends 840 kilohertz pulses. 840 kilohertz pulses will be transmitted by the module, and this signal will go and hit the object and it gets reflected back. So upon the signal is back, the echo signal goes to high state. And how long this echo signal will be high? The time of high output duration is equivalent to the time of flight of the ultrasonic pulse. How long it has taken from the module, the pulses, to travel, hit the target and to return back to the module again. So the time of transmission to the reception. So whatever we calculate the time, it is nothing but the transmission distance as well as the reception distance. So in order to calculate the object distance, we have to take the high level time, which is a echo signal high level time, multiplied by velocity of sound. We already know it is 340 meters per second, and since it is a round trip time, we have to divide it by 2 to get the object distance. As I say, the pinout of the ultrasonic sensor, it requires a 5 volt supply, a ground line, trigger is an input line which comes from your microcontroller, 10 microsecond pulse, and echo will be a output line. So this will get connected to your microcontroller. As soon as the echo signal is high, we can use a timer module to start counting. and we can switch off the timer module when the echo signal goes to low. Then we can calculate the distance based upon the timer module time period. So this is a typical signal diagram or timing diagram. When a trigger pulse is generated, the module sends 840 kHz sound wave, and then upon receiving the return signal, the echo pin will go to high. And this time period is the one which we are going to calculate. So this time period is equivalent to the distance of the object from the module. So in this tutorial, I am going to discuss about a simple application where I am going to use a HC-SR04 ultrasonic sensor, which can measure from 2 cm to 400 cm. So as I said, it has two control lines. One is trigger pin and the echo pin. So the trigger pin is connected to RB0 of your microcontroller, and the echo pin is connected to RB1 of your microcontroller. So the RB0 will be configured as an output pin, whereas RB1 will be configured as an input pin. Upon receiving this echo signal, I am going to use a timer 1 module, which is a 16-bit timer, and I start counting this timer 1 module. When this echo pin goes to 0, I am going to switch off the timer. Then I am going to take the time and use the time for calculating the distance. Once the distance calculation is done, I am going to send that distance value to a LCD. I am going to use a 16x2 LCD, which is going to be connected in a 4-bit mode. In a 4-bit mode, I am going to use port D, D4, D5, D6, D7 is connected to D4 to D7 of your LCD, and the control lines RS register select is connected to D2 of port D, and enable line is connected to D3 of port D. RW bar line, I am going to ground it in a LCD. So in order for us to use the timer 1 module, I am going to do configuration of this timer 1 module using a register called as T1 con register. So T1 con is a timer 1 control register. It's a 8-bit register. So here in this we need to do the configuration part. So here I take this 2 bits T1 CKP-S1 and T1 CKP-S0, which is used for setting the prescale value. What is prescaler? How fast or when I should do the incrementation of a timer registers. That is decided by this 2 bits. For example, if I put 1 here, it is equivalent to 1:8 prescale value. So 1:8 in the sense, for 8 clock pulses an incrementation will happen. For the 8th clock pulse, incrementation will happen. Then the next incrementation will happen for only the 16th clock pulse. Same way, if I put 1:1, for every clock pulse, the timer 1 register will get incremented. If I use 1:2 prescaler, for every second clock pulse, incrementation will happen. So the prescaler value we need to set for a timer. So for this application, for this program, I am going to use a prescaler value of 1:2. For every second clock pulse, the timer 1 register will get incremented. Then T1 oscillator enable, this is used only in your counter mode. So since we are going to use the timer in a timer mode, I am not going to use this pin. Then again T1 sync is used for your counter mode. It is not used here. And timer 1 CS is a timer 1 clock source. Whether my clock source is an internal clock source or external clock source. In case of a timing, we use internal clock source. For counter, we use an external clock source. So now we are going to use it as a timer. So I am going to use internal clock source. So I need to put 0 here. So 0 will indicate I am going to use it as an internal clock source. Then the last bit is for switching on the timer. If I put 1, timer 1 will be switched on. If I put 0, timer 1 will be switched off. Then how to calculate the distance of the object to the module? We have a simple equation here. So first the time is calculated using this formula. So here I take the timer 1 register content. As I say, timer 1 is a 16-bit timer. It requires 2 registers. One is timer 1 high and timer 1 low. So if I concatenate both the things, I will get a 16-bit value. This value is multiplied by the prescaler. So the prescaler is set with the help of this T1 CKP S1 and T1 CKP S0 bits. and as I said, I am going to use a prescaler of 1:2. So prescaler I am going to use here is 2 divided by clock frequency. So clock frequency is nothing but, we might connect a clock frequency of about 20 megahertz to our microcontroller. This 20 megahertz is internally divided by 4, it becomes 5 megahertz. So I can use a clock frequency of 5 megahertz here. So with the help of this, the timer 1 module content into prescaler divided by clock frequency, I can estimate the time. Then using this time substituted in this equation, I can calculate the distance. So we already know the velocity of a sound wave, which is 340 meters per second. In case of a centimeter per second, it will be 34,000 centimeter per second. So this velocity into time, I will get the distance of the object. If I substitute all these values, then final equation I can get the distance equal to timer content divided by 147.05 centimeter. So if I compute this equation, I can be able to compute the distance of the object from the module. Now let us go to the Proteus environment, where we will be building the circuit, and the programming will be done using your Micro C Pro for PIC compiler. So this is a Proteus environment where I have connected a microcontroller, which is PIC16F877 microcontroller with a 20 megahertz crystal, and it is connected with supporting capacitors to produce stable clock frequency. And the memory clear pin is connected to the reset circuit. So here you can see this memory clear is an active low signal. So by default, this pin will be at logic high. As soon as I close the switch, it goes to logic 0. Then the reset operation will be performed. So this is a reset circuit, this is a clock circuit. Then I have interfaced an ultrasonic module here. So this ultrasonic module, as I said, it has 4 lines: 5 volt, trigger, echo and ground line. So the 5 volt is connected, ground is connected, the trigger line is connected to RB0 pin of your microcontroller, which I am going to configure it as an output line, and echo line will be connected to RB1 of your microcontroller, and it will be configured as input line. And in order to measure the distance in a simulation environment, there is a test pin here. So the test pin, it can be connected to a potentiometer. So this potentiometer voltage will be equivalent to that of the object distance. So instead of putting a physical object in a simulation environment, what we are going to do is we are going to adjust this potentiometer, which is equivalent to the object distance. So by varying this potentiometer value, which means that it is equivalent to varying the object distance. If I have a low value of resistance, then the object is very nearby. If I have a high value of resistance, then the object is very far away. So I can vary this potentiometer, thereby I compute the time and then I try to convert it into a distance. So this is the circuit for measuring the object distance from a module. Now let us go to the programming part. So the programming is done using Micro C Pro for PIC. Here, as you see, I have set the microcontroller to be PIC16F877 and the oscillator frequency is set about 20 megahertz. So I connect the LCDs to the microcontroller. So as I said, the pin configuration, port D2 is connected to RS line of LCD, D3 is connected to enable line, D4 to D4, D5 to D5, D6 to D6, D7 to D7. So we have connected the LCD in a 4-bit mode and the corresponding data direction registers are assigned to the corresponding pins. Then we initialize a variable called as calculate distance, integer data, and I use a character array for storing the string of the distance. So we start with the program. So TRISD is configured as an output port because we have connected LCD to the port D. So by setting a 0 to TRISD will make the corresponding pin to go to be output pin. Same way TRISD B0, B0th pin, I am going to use it as an output pin. So I have set it to 0. B1 I have set it to 1, which means I am going to use B1 pin as an input pin. So B0 is connected to trigger line of your ultrasonic module, B1 is connected to echo line of your ultrasonic module. Then we initialize the LCD, then clear the buffer register of the LCD, then cursor is turned off. Then I put a sample string in the first row, 4th position, it will display ultrasonic. In the second row, first position, it will display sensor interface. Then this values will be displayed in LCD for 2 seconds. After 2 seconds, I am going to clear it. Now we do the configuration of this T1 con. So T1 con is set with the value of 0x10, which means so T1 con is set with 0x10. So 0x represents a hexadecimal value, 0x10 means it will be 0, 0, 0, 1, 0, 0, 0, 0. So here you see I have set this 2 bits, T1 CKPS1, T1 CKPS0 to be 0, 1. So 0, 1 means I am going to use a pre-scalar value of 1:2. And this 2 are for counter mode, we are not going to use it. And the clock source, it is set with 0. So clock source set with 0 in the sense I am going to use the timer 1 module in timer mode. So internal oscillator frequency will be used for incrementation of the timer 1 register. Then timer 1 on is set to be in off state. So we have stopped the timer right now. So that is the configuration part, why we need to put T1 con equal to 0x10. Then in a while loop, I initialize the timer 1 registers, both high and low are set with 0, 0. Then first step what we have to do is we have to send the trigger signal from the microcontroller. So I am going to put the port B 0th pin to be 1 for a 10 microseconds, it will be 1. And after 10 microseconds, I am going to change it to 0. So we are generating a pulse, trigger pulse of 10 microseconds here. Then what I am going to do, once I sent it, then the module will transmit the 840 kilohertz pulses will be transmitted. So as the pulses travel, hits the target, it will come back. When it comes back, the echo signal will be high. So I am going to wait until the echo signal becomes high. So exclamatory mark indicates it's a NOT signal. So NOT of port B dot F1. So until the echo signal is 1, I am going to keep on wait here in this statement. Once the echo signal turns to 1, I am going to switch on the timer. How I am going to switch on the timer? In T1 con, 0th bit is your timer 1 on bit. So if I set it to 1, timer 1 will be on. And how long this timer 1 will be on? Until my echo signal goes to 0. So again, while port B dot F1 is 1, my timer 1 will be on. Once my port B dot F1 goes to 0, which means echo signal goes to 0, my T1 con dot F0 will go to 0, which means I am going to switch off the timer. So once I receive an echo signal, I am going to switch on the timer module. Once my echo signal goes off, I am going to switch off the timer 1 module. Then I will get the time. So the time is in 2 registers, timer 1 low and timer 1 high. So what I do, I concatenate these values to make it as a 16-bit value. So I take timer 1 low or with timer 1 high left shifted by 8 bits. So double less than symbol indicates it's a left shift operation. Left shift of 8 bits I am going to do. So I am going to shift it 8 times the higher register, and then I am going to concatenate it with the lower register. Thereby I will get a 16-bit value, and this 16-bit value will be divided by 147.05. So this value is applicable only when my oscillator frequency is 20 megahertz. If you change it to some other value, then this division factor will change. So by using this formula, we calculate the distance. Then I want to check whether this distance is a valid distance, because our module will identify only the objects in the range from 2 centimeter to 400 centimeter. So I am going to check whether my distance is greater than 0 and less than 400 centimeter. If it is so, I am going to convert this integer value into a string value, because I want to put it onto the LCD. So I want to convert this integer value to string. So for that I make use of this integer to string. So I give the integer data and it gets converted into a string in the dist variable. So this dist is a array, character array, which holds 7 characters. My result might not be 7 values. It can be 2 value, 3 value or 4 value. So in order to avoid the unnecessary spaces, I use a ltrim function, so which will remove the unnecessary spaces. Then I try to put this distance on the LCD, and then if it is within this range, this loop will get executed. If it is outside this range, then it will show out of range. So that is how a object distance is measured and it is displayed on your LCD. Now let us look at the simulation part. After compiling the program, an X file will be created. So we can dump that X file to the microcontroller. So select a X file, load it onto the microcontroller, set the oscillator frequency to be 20 megahertz. Then we can switch on our circuit to see whether it is working properly or not. So it shows ultrasonic sensor interface. Currently the potentiometer is set with some value, so it shows a distance of 54 centimeter. As I start increasing it, you can see the distance is increasing. As I start decreasing it, the distance is decreasing. So this is how a proximity sensing can be done of an object. So in this tutorial I have discussed about on how to compute the object distance using an ultrasonic sensor. Thanks for watching. Please subscribe for more technical learning. Thank you.